By the way, I'm gearing this whole thing up to where I can record the review for the exam. By the way, I'm gearing this whole thing up to where I can record the review for the exam. That way you can look at the review a couple of times. Okay. Oh, there it is. All right, what we're going to talk about here, and we talked a little bit about this before as far as the correlation goes, okay, is what we're going to talk about here, and we talked a little bit about this before as far as the correlation goes. Generally, okay, it's at least up front we'll be talking about the relationship that exists between two relationship generally an independent variable, at least up front we'll be talking about the x's and the y's. A couple of relationship between an independent variable. The most normal one is you have time is the independent variable. A couple that we've talked about before is the outcome variable. The most normal one is you have time is the time determines sales. Or does sales, and sales is the outcome variable. Obviously, time is the way you more of a figure that out. Is does time here sales determine these variances? And what I'm doing here is I'm going back. And so the way you work on this, the way you first do this, where we have covariance. And what I'm doing here is I'm going back. And so the way you work on this, the way you first do this is where we have covariance. Help me here one real quick. Anybody? What was that example? And that's called the variance of x and y. What was that? Oh gosh. Cat and dog. What was that example? Anybody got that? Whatever it was. But anyway, so we just plug in the variables. We calculate sigma that we've already determined was the standard deviation. So we just plug in the variables. Sigma is nothing more than the square root of sigma that we've already determined was the standard deviation. And what you have here, and sigma is nothing more than the square root of sigma squared, which is the variance. Standard deviation variance of. And what you have here is you have the standard deviation of x, and that gives you the correlation between these two over the standard deviation of x and times y. And that gives you the correlation between these two variables. Yes, I think it was. You're right. Yes, that's right. All right. Yeah, it was cat dog. Okay. So the different options. Yes, I think it was. You're right. Yes, that's right. The different numbers that are available. It was cat dog. And all you do is you just plug in those numbers. And what you'll be given that were available on the exam, and what you'll be given in real life. And all you do is you just plug in those numbers. The computer's going to calculate for you, or you're going to know this what you'll be given in real life is because it's going to the computer's going to calculate for you. And so now you're going to know this based upon previous history. The correlation between x and y. So you just plug those in. 0.954. And so now here's what you get, okay? The correlation between x and y is 0.954. And so I ask, what does that mean? Now the question becomes, what does that mean? If you know your correlation is 0.954, and so I ask, what does that mean? What does that mean? If you know your correlation is 0.954, I'm going to give you a hint. What does that mean? All right? If, I'm going to give you a hint, correlation, all right? Relationship. If, I think somebody before used the term, were they linked? Or correlation, how much influence one relationship over the other. I think somebody before used the term, were they linked? On the board here, or how much influence one had over the other. And in the middle is 0, and on the end, on the left side is minus 1 here, and on the right side is plus 1. And in the middle is 0, and on the end, on the left side is minus 1. Now, if you see a correlation that's 0, what does that mean? If that number were 0, what does that mean? There is no correlation. If you see a correlation that's 0, what does that mean? If that number were 0, what does that mean? Taking that thought, there is no correlation. What does it mean when you start approaching correlation as a correlation? Now, taking that thought, very strong, right? That's exactly right. What does it mean when you start approaching and sometimes you'll see relatively strong when they get down to very strong, right? 0.5, 0.6. You have very strong, and sometimes you'll see relatively strong when they get down to about 0.5. And this is the way 5.6. Okay. Somewhat strong when you're down around a somewhat strong. Okay, and this is the way and so what that means is not only is it when you're very strong, but is that relationship positive and or so negative? What that means is positive, not only is it very strong, and so you have the same situation on the left side positive of 0 or negative, where there's no correlation, exactly, and it becomes a and so you have the same situation on the left side of and the way 0, that slope looks where there's no correlation, just like we've talked before, and it becomes a very strong negative correlation. And the way that slope looks is just like we talked before.
I'm going to draw a little.
And so this is a very strong positive correlation, right?
So here's y.
So this thing is actually going to look,
it's going to have like the steepest slope you
this
can
is a very strong positive correlation, right?
It's going to look
so
like
this
that.
thing is actually going to look,
It's going to have like the steepest slope.
So
you
whenever
can
you
possibly
see
think
a
of.
strong correlation, you're going to get a slope that is
like
off
that.
the charts. Anybody ever been to
very
snow
steep
skiing? So whenever you
And a
see
black
a
diamond,
strong
a double black
correlation,
diamond, or what
you're
they
going to get
the
the
slope
slope
that is
suicide
off
hill
the
or whatever.
charts.
Anybody ever been
These are
to
worse than
snow
the
skiing?
suicide hills. Okay,
And a
they're
black
like
diamond,
cliffs.
double black diamond, or what
Straight
they
down.
or the
All right.
suicide hill or whatever.
Now, if
these
you
are
see
worse than the
a
suicide
correlation
hills. Okay,
that's
I mean they're like
somewhat
cliffs.
strong,
Straight
down.
and that would be
All
about. What would you say somewhat
Now,
strong
if
would
you
be?
see a correlation that's somewhat strong, okay, and that
0.75.
would be
Let's say
about
what would you say somewhat
somewhat
strong
strong.
would be?
Yeah, probably about a 0.3.
0.75.
So you
Let's
would
say
see a slope that looks
somewhat
a
strong.
a whole lot less steep. Yeah,
Okay.
about
But it would
probably
still
about
go up
0.3.
and to the right.
So you would see a slope that looks a little.
Now, and if you see a
whole
slope
lot
of
less
0,
steep, boom.
that just but it would still go up and to the right.
All right. All right. Now, and if you see a slope of 0, boom.
Correlation
That just goes straight
is not correlation is not the slope, but they are the formulas.
Correlation
slope is not necessarily correlation is not the slope,
correlation.
but they are the formulas. They're very tightly
intertwined.
Are part
And
of
you can think
correlation.
of the slope as more
they're,
of a.
they're very tightly
you can think.
intertwined. You can think you know what you can
And
think
you
of
can
correlation
think of
as
the
more of a
slope
ratio
as
to understand
more of
what
a,
the slope is really saying.
you think.
You can think
Loosely,
you know what you can
that's
think
a little
of
bit of a
correlation
Shelbyism, so be
as more of a
careful.
ratio,
But
to
you
understand
can
what the
kinda-
slope
you
is
can kinda
really
make
saying.
that
association between
Loosely,
the slope
that's
and
a
how
little bit of a
large of a
Shelbyism,
number
so be
that
careful.
is between 0
but
and
you
1
can-
if
you
it's a
can kinda-
positive
you can
slope.
kinda
make that association between
Okay.
the slope and how large of a number that is
So
between
now,
0 and 1 if it's
let's
a
extend
positive
this
slope. one step further,
Okay.
slightly further.
Is what would happen?
So now, let's
where
extend
would
this
you
one
be if you
one
saw
step
a
further,
slope that looked like
slightly further.
this? Is what would happen? Where would you be?
Yeah, which side
if you
of the
saw
0
a
would you
slope
be
that
on
looked
then?
like this?
To the left. That's right. Exactly. And so that'd probably be a slope. Which side of the 0 would you be on then?
You'd probably see a slope about
To the left.
0.7,
That's right.
0.8.
Exactly. And so that'd probably be a slope. You're looking
That would
down
be
the
a
hill.
nice slope.
That you'd probably see a slope
Slope
about.
about 0.7, 0.8.
You'll see that. You'll see that again. I assure you. You're looking down
in
the hill.
about 3 weeks. Okay.
You'll see that. You'll see that again. I assure you in about 3 weeks. Okay. So what I need for you to do is go to 525D, and I'm actually going to give you the standard deviations. So what I need for you to do is go to 525D, and I'm actually going to give you the standard deviations. And I'm going to give you that the standard deviation, okay? And these are sigmas, so they're x's and
I'm
Y's.
going to give you that the
They're
standard
sigmas, so it's
deviation
of the population. And these are sigmas, so
And
they're
so
x's and y's.
You see,
they're
you
sigmas,
see
so
you're going
it's
to have a
of the
long
population.
math problem. Again, I'm not overly interested in how well you
And
do
so
mathematics or
you
algebra.
see that
I'm
you're going to have a
mostly
long
interested
math
in,
problem.
Can you
Again,
take
I'm not
what
overly
you- or
interested
what
in
you
how well you do
calculate, or get
mathematics
into
or
your
algebra
report
and figure
I'm
out
mostly
what's going
interested
on
in,
there. Can you
right?
take
what
what I'm going to
what
tell
you
you
calculate
is
or
that
given to in your report
and
sigma
figure out what's
of
going
X,
on there.
Y
Right.
equals 87.
So what I'm going to tell you is that
Okay.
sigma of x
y
is equal to 7.87.
1.
Okay.
And
Sigma of
y
x
is
equal to
7.81, 11
Okay.
point, and sigma of
Call
y
11.4.
is
Let's
equal
call that
to
7.8, just to make this a little bit easier.
11 point,
Right.
call 11.4, and let's call that 7.
No, that's an 87.
Just to make this a
87.
little bit easier.
Yes. That's a standard deviation of x and y. That's an 87.
Just part of the formula.
87. Yes. That's a standard deviation of x and y. Okay. Just part of the formula. Okay. Okay. So the question that Tanner brought up was, okay, so what does that mean? Is that a 98%? So the question
No,
that
it's not a
Tanner
98%.
brought up, what
Was,
that says
okay,
is there's
so
a
what does that
strong
mean? Is that a
correlation or
98%
strong relationship
And it's like,
between
no,
x
that's-
and
it's-
y?
it's
It might
not a
be
98%.
times What that
and,
says is there's a strong
and sales, or it might be
correlation or
advertising
strong
and
relationship
sales.
between
It
X
might
and Y.
be,
It might be time,
how much
and
what the temperature is outside,
and sales,
how
or it might
many,
be advertising and
ice cream
sales.
cones are
It
consumed.
might
whatever
be
whatever that
how many,
relationship is
how much
between
what
X
the
and Y.
temperature is outside.
And so
how many,
Tanner's question
how many
was,
ice
well, does
cream
that mean it's
cones are
98%?
consumed?
Whatever that
It's
relationship
a
is
relative
between
number.
X and Y.
Okay.
And so
remember the scale
Tanner's
we had
question
0 to
was,
1,
well, does
1
that
is
mean it's 98%
or 0
and it's
minus
no.
1?
It's a
So
relative
what you
number.
do, okay, and remember the
more
scale we had 0 to 1,
valuable
1
becomes
to
R
1
squared.
or 0 to minus 1.
So what
if
you do,
square, and this is going to be a very
more
powerful
valuable
number
as
becomes R squared. You begin understanding statistics.
So
because
if you square, and
this
this
is
is
going to be a very powerful
0.97
number
times 0.97,
as
what is that?
you begin
80-something?
understanding statistics, because if you
What is it,
square
point-
that up,
Oh no, it's
what
what
is it?
0.97 times 0.97. What is that?
Okay.
80 something.
Now I can
What is it,
begin
point-
moving
oh
towards
no, it's what is
Tanner's
it,
question
0.95?
that says 95%
Now
of
I
the
can
reason
begin
why
moving toward the
Tanner's
Y
question
outcomes
that says
occur.
95%. Now we can't talk
95%
percentages.
Not
Of the
necessarily
reason
probabilities,
why
'cause we can still
the
talk
Y outcomes
probabilities is a whole other
occur.
subject, a whole other subject when we get into
Now we
here.
can't talk
But you
percentages.
could say that
Not
95%
necessarily
of the
probabilities,
reason
'cause we
why
can still talk
occurred probabilities
is
is a whole
accounted
other-
for
a whole
in
other
X.
subject when we get into here.
But you could say that 95% of the reason why occurred what is accounted for in X.
Yep.
Yep. And you can actually determine statistically, what is influencing sales, and that's what you can actually determine.
Bring it
Statistically,
to the
strategy
of a corporation,
what is
or the strategy of
influencing
a company,
sales, and that's
large
what
or small.
if you're small, you
bring
have
it to
investors.
back
If you're
to
large, you
the
have Wall
strategy
Street,
of a corporation,
that
or
are
the strategy
investors,
of
or
the
the
company,
analysts,
large or small.
And
If
so,
you're small, you have investors. If you're large, you have Wall
to
Street.
begin understanding
that are
is
investors, or the analysts. Anybody
and
inside
so
an organization,
what
certainly
you'll-
at the
what you
CEO,
need to
president level,
begin
if you're a small business,
understanding
the president
is,
and the CEO
as
probably one and the same.
anybody inside an
sometimes.
organization,
certainly at
but
the
you need
CEO,
to understand
president level,
what
if you're a small business, the
influences
president
sales.
and the CEO probably one and the same.
If you,
sometimes.
as the owner,
But you need to
or
understand
the CEO
what
of that business, or the
influences
president, or
sales.
even the CFO, the vice president of marketing,
If
and
you,
sales, whatever
as
the case might
the
be,
owner,
if you don't
or the
understand what
CEO
drives
of that
sales,
business,
or the president,
and what
or even
drives
the CFO,
profits,
the vice president of
what's
marketing,
going to
and sales,
happen?
whatever the case might be, if you don't understand what drives sales and what drives
you're going
profits,
to be pursuing
what's going to
your,
happen to
your
you.
excellence elsewhere.
Yeah,
Eventually.
exactly that, and that's kind of a nice phraseology to
Yeah,
say.
you're going to
The other
be
one is
pursuing
you'll be
your excellence
spending more
elsewhere.
time with your family, and you're 45
exactly
years
that,
old, and that's kind of a nice phraseology to say.
So that's
the
not-
other one
that's
is
not the reason.
you'll
So,
be
and much
spending
like,
more time with your
I mean,
family.
think
and you're
about,
45
again,
years old,
I
right?
don't
It's
want to
like, disparage any
that's
local
not-
corporations,
that's not the reason.
but
There is a
and much
CEO,
like
there are
think
CEOs
about,
after
and again,
CEO.
I
In fact,
don't
there's
want
a
to
CEO today.
disparage
I
any
can assure you
local
out of
corporations,
all
but
there is a
the
CEO
companies on
there are
NASDAQ
CEOs
and
after
CEO. In fact, there's a CEO
Dow
today.
Jones Industrial
I can assure
Average.
you,
Any-
out of
there's a
all
company
right now,
the company's
on
CEO is
NASDAQ
being
and
terminated
because he doesn't understand
Dow Jones
our
Industrial
square.
Average.
There's a company
He or she
right
does
now
not understand
whose
what
CEO
drives
is being
their
terminated
revenues or
because
their
he doesn't
profits.
understand R squared. Okay,
He or
that's
she
how
does not
powerful that
understand
number
what
is.
drives
and so
their
then
revenues
you can get
or
not
their
only an R
profits.
squared for X, but you can
Okay.
get R squared
That's
for
how powerful
X1,
that number is.
X2,
X3,
and so
because
then
profit
you
and
can
sales
get not
are made
only
up
an
of
R
many, many
squared for
different variables,
X,
right?
but you can get R squared for X1.
That's why that's such
X2,
that becomes such a
X3,
very
because
important
profit and sales are
concept
made up of many
as
different
time goes
variables,
on.
right? But the key here right
That's why
now
that's
is
such a-
that
that
you
becomes
know
such a
that there is
very
a strong
important
relationship
concept
between
as
X
time goes
and
on.
Y. Between
But the key here right
antecedent,
now
the
is
input
that
variable,
you
and the
know that
outcome
there is a
variable,
strong
which is
relationship
Y.
between X and Y, between the antecedent, the input variable, and the outcome variable, which is Y. All right. So now I want to talk about binomial, the properties of binomial. There are four. Let me go one more here. So now I want to talk about binomial, the properties of binomial. Just means there's two outcomes: success or failure. Yes or no. Binomial just means there's two outcomes: success or failure. In Russian,
Yes
whatever
or
language
no.
you want to go with.
No,
There's
if
two
you're in Spanish,
outcomes
net
on each
i
try.
ya,
Okay.
net i da,
And
in Russian,
the probability
whatever
on that
language you want to go with
success is
is two outcomes
denoted
on
by
each trial.
P.
Okay.
All right.
And the
And-
probability
and the
on that
probability does not change
success
from trial to
is
trial. So when you flip
denoted
ahead,
by
and you flip ahead,
P.
and you flip ahead, the probability is always the
Right.
same.
Whereas
And
there are,
the
and there's-
probability does
I'll
not
show you
change
another
from trial to
example
trial.
later
So when you
on,
flip ahead and you flip
where,
ahead and you
or
flip
another
ahead, the
situation
probability
later
is
on,
always the same.
whereas there are, and there's,
If
I'll
you
show you
don't
another example later
have
on,
this,
where, or another
probability of
situation
success,
later on, where
and there is a change on each
if you don't
additional
have this
outcome or test,
probability of success,
you can't use
and
binomial.
there is a
You
change
have to use something
on
else.
each
and also the trials are
additional
independent,
outcome
meaning that
or
one
test
you
outcome
can't use
does not
binomial.
influence
You have
the
to
other
use something
outcome.
else.
Okay?
And also
if you
the
flip
trials are
ahead,
independent,
in
meaning
theory,
that one
if you flip ahead,
outcome does not influence. Or you flip a coin and you get ahead.
if you flip ahead,
And it
in
was
theory,
50%.
if
What was
you
the
flip
probability that
ahead,
you're going to get ahead on the second one? Or you flip a coin
50%.
and you get ahead.
There's no relationship.
Now,
And it was a
you get 10
50%.
heads
What
in
was
a
the
row.
probability that you're going to get ahead
Okay.
on the second one?
Now you're going to go, well, wait a
50%.
minute.
There's
I
no
think
relationship.
there's some influence
Now,
here.
you get 10
But
heads in a
in
row.
theory,
Okay.
there is
Now
the
you're going to
first
go, well,
head
wait
or
a
the
minute.
first tail has no
I
effect
think
on the
there's
second.
some
independent
influence
events.
here. But in theory,
It's pure.
there is
pure
the first
serendipity,
head or the
pure
first
luck,
tail has no
pure,
effect on the second
pure
events.
independent events. Okay, it's pure. It's pure serendipity, pure luck, pure chance. Okay. Okay, we're back in action. Okay,
Hopefully I don't do it again.
Happy trigger finger today. All right. So binomial
Hopefully I
probability.
don't do it again.
Happy trigger finger today. All right. So binomial probability distribution. So we're interested in how many successes we get in n number of trials. You're going to
So
have
we're
25
interested in
trials.
how
How many
successes
successes
we
are you going to get out of 25 trials?
N
Are you going to get
number
one
of
trials?
trials.
You're going to
Two, or are
have
you gonna get
25
three?
trials.
Okay.
How many
And
successes
so
are you going to get
X
out of 25
is the number
trials? Are you
of
going to get one,
successes
are you going to get
occurring
two, or are you going to get
in
three?
those trials.
Okay. So it's an n
And
an
so
x sort of discussion.
X is the number of successes occurring in those trials.
So it's an n and an x sort of discussion. And here is the
Pretty
handy
simple,
dandy
basically.
formula. Okay. For the probability of the binomial
And here
probability
is the
function.
handy dandy
Okay.
formula.
And you're going to see here, hopefully a little bit
For
more comes up. Probability of the binomial probability function. Okay. And you're going to see here, hopefully a little bit more comes up. All right. And what you're going to see here is our old friend, the number of experimental outcomes. Remember this formula? And what you're going to see here is our old friend, x times n minus x factorial,
The number of experimental outcomes.
Remember this formula?
Possible
N
outcomes.
factorial over x times
And
n,
now
n minus
we're going
x
to multiply
factorial
that
times. We're going to add
number
a
of
second component here. We're going
possible
to multiply that
outcomes.
times
Okay.
a probability
And now
associated
we're going to
with
multiply
the binomial
that
nature
times
of. We're going to
the
add a second
outcome.
component here. We're going to
And
multiply
that
that
formula
times
goes
a
as
probability
follows.
associated with the binomial nature of the outcome. Comes up, and that formula goes as follows. And that is, I'm not just going to read this, just make sure you understand it. And it's a probability of a particular sequence of trial outcomes.
And that
X
is
X. I'm not just going to read this,
successes
just
in
make sure you understand it.
So
And
you
it's a
have
probability of a
X number of
particular
successes,
sequence of
you have
trial
10
outcomes.
trials,
And you plug it
X
into this
successes
handy dandy
in N
formula.
trials.
Okay, so and you
You
come
have
up with your binomial
X number of
probability
successes,
distribution.
you have N trials,
and you
actually,
plug it into this
let's be
handy
more
dandy
specific,
formula.
is what is
Okay.
the probability
and you come up
that
with your
the
binomial
value of
probability
X is
distribution.
going to occur.
Or actually, let's be more specific, is what is the probability
Or X
that the
successes will
value
occur
of
in this
X
case.
is going to occur. Okay?
Take
Or
an
X
example.
successes will occur in this case. All right. They're worried about a low retention rate.
Take an example.
They've seen a turnover of 10%. All right. And
They're
so
worried
they
about
want
a
to
low
estimate
retention
the
rate.
probability
At
They've seen
10%,
turnover
that a
of 10%
person will
not
not
be with the company next year.
So
And
they're
so
gonna
they want
choose-
to estimate
they're
the
gonna choose
probability
from all the
at
hourly
10%
employees,
that a
and there
person will not be with
are-
the
they're gonna have
company
to give me
next
an-
year. So they're going to
They say how many
choose. They're going
employees
to
were yet?
choose from all the hourly employees.
we'll have to get it
and
from
there
the number
are.
of employees.
They're going to have to give me.
You have your
an-
probability here.
Did they say how many
0.1
employees
P.
were yet?
Okay.
You have.
We'll have
you're
to
gonna
get it
choose
from
3 at a
the number of
time,
employees,
which is your X.
You have your probability
okay?
here,
and
0.1
then we're going to have to
P.
be given an
Okay.
N. You're going to choose 3 at a time, which is your X. Okay. And then we're going to have to be given an N. All right. So the probability that the first employee leaving and the third employee staying, okay, so it's an S, FF. So the probability that the first employee leaving and the third employee staying, okay, so it's an S. And so here is the actual calculation, okay, is the way that comes out. All right. And so here is the actual calculation. Three outcomes, okay. They can stay, okay, leave. So there are three outcomes. Stay. They can stay, leave, stay, leave, and leave is the failure. Leave, stay,
and
leave,
so you just
stay,
plug that
stay,
into that formula, the handy-dandy formula that you had before over on the right-hand side,
leave is the failure.
associated with the
And so you just
probability.
plug that into that
but you have
formula,
one
the
additional
handy-dandy
step
formula
here
that you
had before over on the right-hand side, associated with the probability. But you have one additional step here, is you have to insert the probability function, which includes a discussion or a scope of this. You have to insert the probability function that says, okay, how many possible outcomes were there? A discussion or that's why scope of this moved over to 2.2 analysis that says, okay, how many possible outcomes were there? So here's basically what you were given in this problem. Probability was 0.1 n. Okay. So here's basically what you were given in this problem. Was 1. Probability was 0.1 of 1 n success. Okay. You had 3. You had all these names. X was 1. Okay. N was 3. 1 success. Okay. And you pulled them out one at a time. So you had all these names. Okay. Okay. N was 3. Okay. And you pulled them out one at a time. Okay. All right. So now what I want you to do is hit B. 531 B, E, and D. Just do B, E, and D. Don't do all of them because I've got to hit B. This will get much easier and D for two reasons. Just do B, E, and D. Don't do all of them. This binomial probability distribution. This will get much easier. There's two reasons. Tables that have been created for all this binomial probability distribution table that has been also within tables that have been created. Probably all the software. There's a binomial distribution. I'll show you how to use that. And also within most of the software, probably all the softwares, there's a binomial distribution. And we'll do the same thing for Poisson. We'll calculate for you as well. And all the tables are already preloaded. Okay. And we'll do the same thing for Poisson in a few minutes. So now, let's take a look at the example we had before. So now, Evans Electronics. Let's take a look at the example we had before. We're going to use a decision tree. There's another way to look at the same problem. Evans Electronics. Decision trees. Again, if you're a visual, and we're going to use a decision tree. There's another way you understand situations is through visualization. Decision trees. Again, if you're a visual, if you're of choice. If the way you understand situations is through visualization, decision trees are your leaves and stays. Okay, because it just kind of easily comes out and makes sense. So here's leaves and stays. Okay. All right. And it'll just build up. Get the probabilities come up. All right. One more column here. Yep. There we go. It'll just build up. All right. The probabilities. All right, so here are your probabilities. One more column here. You see here, it's a leave and stay. Right. Binomial. That's why it's called binomial. All right, so here are your probabilities. You leave or stay. Here, first worker, leave and stay. Second worker can leave or stay. That's why it's called binomial. Trees out to a third worker. You leave or stay. First worker leaves. And so when you plug those leave or stay, and you're going to get and then that trees out to a third worker that can leave and stay. 0.001, 0.009. And so when you plug those formulas in, you're going to get 0.001, 0.09. And these numbers will eventually add up to 1. 0.8, 0.081, because this is these numbers everything is will eventually add up to 1. So, that's the decision tree. Makes sense? Because this is everything is real easy, just a binomial. Boom. So, you go leave. That's the decision tree. Makes sense. Run the stay side, and the next person stays or leaves. It's a real easy, just binomial. You have the probabilities that you run at the end. Leave, stay. Okay, and then you run the stay side, and the next person stays or leaves, and then you have the probabilities that you run at the end. Okay. All right. I'm going to, let's forego 531A. I think you can do the decision tree on your own. All right. I'm going to, let's forego 531A. I think you can do the decision tree on your own. There's handy-dandy tables in the back that I want to go to next. Okay. And you'll start using these tables. There's handy-dandy you'll start using these tables more and more. Okay. As we go through, and you'll start using these tables. You'll see T distribution. You'll start using these tables more and more. It's Appendix B as we go through the next couple chapters. The binomial tables start on distribution, but it's Appendix B, and the binomial tables start on 985. Yes. And it gets even better than that, is that if you put these numbers into maybe I'll demonstrate that on Thursday. And it gets even better than that, is that if you put these numbers into you can actually put these into the software and
Just does it. It's kind of a sideline on Thursday.
And the reason we do
You
this
can actually
to
put
kind of
these
give you the
into
ground
the
up,
software,
ground level up, or the
and it just
basics
does it
up,
for you.
is that way you know
The
what the reason we do this to kind of give you the ground up, ground level up, or the basics up, is that way you know what the theory you're going to go straight to the tables in behind T distribution. You're not going to calculate the handy dandy tables every time, or the Z distribution. Normally, you're right. You're going to go straight to the tables T distribution. You're not going to calculate the T distribution every time, or the Z distribution, or the binomial. And even the tables it's just not necessary at this point, because basically what they've done is the tables in the back that start on 985, and even they try to anticipate every type of combination is the tables in the back that start on 985. The probability they try to anticipate every type of combination between the book, the probability and the N chose an X at a time. 4 or 5 pages here, right? It'd be it would be a book that wouldn't even come close to being like N's and X's that are 4 or 5 pages here, right? Okay. It'd be probably a book bigger than there's room for all the different. So not only are the tables unnecessary, or not only is the formula unnecessary, but the tables become obsolete as well. So not only are the tables unnecessary, or not only is the formula unnecessary, but the tables become obsolete as well as you move into the software side of the house. Okay. Okay. So what I wanted you to do is go to Appendix B 985 in your textbook, and if you don't have one, I think Appendix B is the same in the older version too. So what I wanted you to do is go to Appendix B 985 in your textbook, and if you don't have one, I think Appendix B is the same in the older version. And you look up N is 3. Just go to Appendix B in the old 0.10. Okay. And you look up N is 3 and P is 0.10. And that's probably going to be N is 3. And that's probably going to be N is 3, 3 and 0.10, right? And you'll see a 0.243. Yeah, you'll see that. There it is. All right, so you'll go to 0.10, right? Okay. And you'll see as you look up the p-value. The whole tables are driven by the p-value. All right, so you'll go to page 988, and then you have to do the combination of the p-value, which p-value. The tables are driven by the p-value across the top, and then you have to do the combination of the p-value, which in this case was 0.10. Okay, and then it'll just tell you what the probabilities are for each one of those choices. So you don't even have to use the you don't have to use the tables. Tell you what the probabilities are for each one of those. Just a nice way to choices to quickly. So you don't even have to use the you don't have to use the tables. You don't have to use the tree diagram. The other thing, it gets a little bit better than this when we get into Poisson. The understanding what is the probability. So what you can do from here. Does everybody have that? Everybody able to find that? It gets a little bit better than this when we get into Poisson. But so what you can do from here. Does everybody have that? Everybody able to find that on page 3. And yeah, so it would have been on page 988. Does everybody see how we got that? And 3. Does everybody see the 0.243? So it would have been on page 988. Does everybody see how we got that? One at a time at a p.10. Does everybody see the 0.243? It's way in the upper one at a time. Yep. Is where on one page 988 at a p.10, way in the upper left-hand corner. It's way in the upper left p-value. The probability is on page 988. Of a success, in the upper left-hand corner, and then you'll see the p-value, and then the probability is 0.10. What's the probability of one success? Of a success out of n, okay. And then you'll see n, and then choosing. Got it. What's the probability of one success out of n? 243. Got it. Okay. And that ends up being. Got it. 0.243. Just look for 0.243, and then you can kind of reverse engineer. Okay. Back into. Got it. Just look for 0.243, and then you can kind of reverse engineer back into it. Okay. Okay. So for 531C, okay, 531C. So for 531C, okay, that we decided was a 0.36. That we decided was a 0.36. 0.36, if you calculate that out, yeah. Just verify that on the table. If you calculate that out, and not at p equals 0.6, but at the p-value you used for that one, which was. Just verify that on the table, and not at p equals 0.6, but at the p-value you used for that one, which was what, 0.4. Yeah.
This is an absolute universal table. Yeah, absolute universal table. Somebody, what happened here is somebody created
This is
these
an
tables
absolute
for you.
universal table.
Okay. Yeah, absolute universal table.
And here again,
Somebody, what
table
happened
not
here
only
is somebody
has the
created
running
these
the
tables
formula
for
become
you.
obsolete. Now the
Okay.
tables are obsolete.
And here again,
the table not only has the running the formula become obsolete.
Now, if you ran
tables
that
are
at
obsolete,
0.6, you would get another value, right?
What value would you get at
These
0.6?
are all loaded in the computer.
If you ran
now,
it
if you
at
ran that at
0.6,
0.6, you would get another value, right?
Yeah,
What value would you get at
0.16?
0.6? Right? If you ran it
So
at
if you had a
0.6,
probability,
okay, of success of 0.6,
Yeah,
now
0.16.
your probability,
Right.
your overall probability.
So if
would
you had
go
a
down.
probability,
okay, of success of 0.6, now your probability, your overall probability would go down. Just as before, you can calculate your expected value, variance, and standard deviation. I'm going to home in
Just
on,
as
on
before,
exactly what you're going to need
you can
here
calculate
right away. Your
the-
expected
all-
value,
all I'm
variance,
gonna-
and standard
all you're gonna do from
deviation.
this-
I'm going
from
to
this
home
point on
in on
is
on
figure out what
exactly
your
what you're going to need
expected
here
value
right
is
away.
for
all I'm
the
going to
mu
all you're going
or
to do
for
from this
the
from this
actual
point
number.
on is figure out what your expected
And
value is. That is the
for
calculation.
the
The
mu
n
or
times
for
p.
the actual
Okay.
number.
What was the n?
Okay.
And on yours, that is the calculation.
Two.
You take
What was
n
the p?
times p. Okay.
0.4.
What was the n?
So it was 2 times 0.4, so it would have
on
been
yours?
two. What was the p?
1.4.
0.8. It would be
So it was 2 times 0.4, so it would have been
in this example,
it'd be 1.8. It'd be 0.8. That's right. Okay. In this
It ends
example,
up
being 0.3. Shoot. Sorry about that. I thought I had it on airplane mode. Shoot. Sorry about that. I thought I had it on airplane mode. Telemarketers always call it the worst time, don't they? All right, and if you ran that up, but the real
always
value
call it the
here is
worst time.
0.3 employees. That would be the probability that. All right,
Or
and if
the-
you ran that
you
up, but
get
the real
0.3
value
employees. Now,
here
can you
is
get
0.3
employees?
employees.
That
would
really.
be the probability.
But
that-
statistically, you can get
or
0.3
you
employees.
get
so you'd
0.3
manage to that
employees. Now,
number.
can you get 0.3 employees? Not really, but statistically, you can get 0.3 employees, and so you'd manage to that number. And so, as we talked, what's the expected value of x at 2 trials? All right. And
Okay.
so,
And
as
you
we
just go
talked,
2 times
what's the expected
0.4
value of
from the
x
from the
at 2
example
trials?
problem that we had before.
Okay.
And then
you
you
just
just
go
go
2 times 0.4 from the example problem that we had before. Okay. And that'd be a 0.8. Okay. All right. Let's hit Poisson. All right. This is an intriguing sort of probability. Okay.
This
Because
is
what
a,
you do here is we're cross-cutting.
an intriguing-
Okay. We're
intriguing
cross-cutting
sort of
frequency
probability.
Okay.
With
Because what you do
time.
here is we're cross-cutting.
Okay.
So
Okay.
where before we
We're
had X
cross-cutting
and Y
frequency
and neither one of those were time.
with
now we're
time.
saying, okay, what
Okay.
happens when you
So where
introduce
before we had
time?
X and
and
Y,
these are used
and
in neither one of those were
multiple
time
situations.
Now we're saying, okay,
In fact,
what happens when you introduce time? And these are
we
used
do that here
in, in the
multiple
university
situations.
All right.
In
we
fact,
have a person at the front desk.
yeah.
Anybody ever met Brenda down there at the front
we
desk?
do that here,
Brenda
okay,
down there
in
at
the
the front desk.
university.
Okay.
All right.
And we
We
have
have
to
a
figure
person
out
at the front
how
desk.
many
Anybody ever met
calls
Brenda
are
down
going
there
to
at the
come
front desk?
in. And what's the
Brenda down there at the
probability that
front
we're going to lose a
desk?
call
Okay,
if she's
and
not
we have
there
to figure
between
out
the
how
hours
many-
of 5
how many
calls
calls
are
are
going to come in? And what's the
You can
probability
actually
that we're going to lose a
calculate how many
call if
people are
she's
gonna
not
call
there
in
between
from
the
a
hours
probability
of
perspective
5
based
and
upon
7?
the Poisson tables.
You can actually
Called
calculate
Poisson.
how many people are going to call in. And it was, the
probability
guy's name was
perspective, based
Simeon
upon the
Poisson.
Poisson tables.
It's called Poisson. Okay.
I don't know,
And it
12
was,
BC or
the
something.
guy's name was
Anyway,
Simeon
so-
Poisson. And they're discrete random
12 BC or
variables.
something.
Okay.
Anyway,
and they
so-
can be an infinite number. So 0,
and
1,
these-
2.
they're discrete.
Discrete random variables. Okay. And they can be an infinite number. So 0, 1, 2. Discrete. So let's go through an example here. All right. So let's go through an example. So here's a couple of number of knot holes in linear feet. Okay. Linear feet
here's a
is
couple
is in
of,
some respects a time
number
or
of knot
distance
holes
parameter.
in linear
The
feet.
number of vehicles
Okay.
arriving
Linear
at a
feet
toll
is
booth in
a-
1 hour.
is in some
Anybody
respects
been through a toll booth?
time or distance
Anybody ever been in a line at a toll
The
booth?
number of vehicles
Okay.
arriving
Somebody
at a
has
toll booth
calculated
in
that
1
they
hour.
needed.
Anybody been through a toll
using
booth?
Poisson distribution
Anybody ever been in a
tables.
line at a
Somebody's
toll
calculated
booth?
how many
Okay.
toll booths you
Somebody
needed
has
in order
calculated
to
that they needed
satisfy using
90%,
Poisson
let's say
distribution tables.
90% of
Somebody's
the
calculated
demand
how
that
many
comes
toll
through those
booths
toll
you
booths.
needed in order to satisfy Okay.
90%, let's say 90% of the demand that comes through those toll booths.
This is kind of my home turf.
My home turf is Bell Labs. Bell Labs was the previous AT&T.
This is
or it was a part of AT&T in days gone by.
My home turf is
And
Bell Labs.
we
Bell
would
Labs
actually
was the
size
previous
phone
AT&T,
systems.
and we still
Or
do
it
that
was a part
today.
of
Or that's
AT&T
still
in days
that
gone
is still
by.
done today.
And
everybody
we
has
would
a cell
actually
phone, right?
size phone systems.
And we
Okay?
still do that today. Or
Everybody has a cell
that is still done today. Everybody has a cell phone, right? No. Everybody has a cell phone. Okay. If
Everybody has a cell
everybody
phone?
in this room picked up their phone at the same time and tried to dial, what might happen? Everybody has a cell phone. Okay. If everybody in this room picked up their phone
everybody in
at
this
the same
entire
time and
building
tried to
picked up
dial,
the phone at
what
the
might
exact
happen?
same time,
What would really likely
okay,
happen?
if everybody in this entire building picked up the phone at the exact same
You wouldn't
time,
overload, but a lot of
probably about
really
10%, maybe a little bit more, would just the calls just wouldn't go through.
You wouldn't
And it
overload,
would
but
force
a
you to
lot
redial.
of probably about 10%, maybe
And
a
that's
little bit
because
more
back at
would
the
just the
cell
call just
tower,
wouldn't go through.
okay, and
it
these
would
are
force you to
might
redial.
be old terms,
But they have what's called
okay?
mobile telephone
and
switching.
that's because
office.
back at the
and it
at the
keeps
cell
track,
tower,
and it
okay, and
has
these are
only a
might
certain
be
amount
old
of
terms,
channels,
but they have
that
what's
can
called
come
mobile
through
telephone
on the
switching
specific
office.
radio
And it
frequency
keeps
that you're
track,
using on your phone.
and it has
only
and
a certain
some
amount of
engineer
channels that can
sat
come
down and
through
said,
on the
okay,
specific
we're gonna
radio
need
frequency that you're using on your
124
phone
channels to serve
and
Batavia.
some engineer
Now,
sat down and said,
does that
okay,
mean everybody
we're
in
going to need
Batavia will never have a drop
24
call
channels
to serve
No.
Batavia?
Okay.
That means
Now,
they're going to
does that
probably
mean everybody
engineer
in
that
Batavia
thing to
will
about
never have a drop call?
0.9 on the Poisson table.
No.
When you take time,
That means they're going
and
to
use
probably engineer that thing to about
in a
0.9
call center. Anybody working
on the
call?
Poisson
Who works
table.
at the?
When you take time,
Oh, here we go.
and use
I
it.
assure you, at the
Best
in
Buy.
a call center. Anybody working at a
Best
call?
Buy?
Who
At
works
the Best
at
Buy.
the? Oh, here we go.
Do
I
you
assure
have 50
at
people?
the,
Are all
Best
50
Buy.
people always there at the
Best
same
Buy?
time? At the Best Buy?
No.
They vary that.
Do you?
And
do
the
you
reason,
have?
and
do you
there's
have
a
50
reason
people?
for that, because how many
Are all
customers
50
do you
people
get
always
at
there at the
noontime
same
on a
time?
Saturday?
No.
They vary that. And the reason,
boatload.
and there's a reason
Okay.
for that, because
How many people
customers
do
do
you get
at noontime on a
at
Saturday?
noon on a Monday? A boatload.
And so
Okay.
they have staff
How many people
using
do you
these
get
Poisson
at,
tables to
at
figure out
noon
how many
on a
people
Monday?
they need in that store given
Any
and
specific
so
time.
They
And
have
everybody has their
staff
schedules,
using
and
these
there's some
Poisson
guy,
tables
and
to
it's
figure
probably- it's
out
not even some
how
guy,
many
it's probably-
people
they just
they
probably
need in
plug
that
it in
store given
based upon
any
the
specific
number of
time. And
clicks
everybody
that come
has their
to the
schedules,
seats
and there's
coming
some
to the
guy.
front door.
and It's not
They
even some
keep
guy.
track
It's
of
probably
all
they just
that.
probably
And
plug
they
it
will
in
staff up
based
accordingly.
upon
It's
the
kind of-
number of
it's
clicks
really
they
a
come
cool
see through
probability
coming through the front door.
distribution. You can apply it to almost
they keep
anything
track
that
of all
has
that,
time,
and they will staff up
so-
accordingly.
It's really a cool probability distribution. You can apply it to almost
Uh,
anything that has time.
You have equal lengths.
Okay, so a minute to 2 minutes is
uh,
always 60 seconds.
You have equal
right?
lengths.
An
Okay?
hour
So
is always
a minute
60 minutes. To 2 minutes is
1
is
hour
always
to 2 hours
60
is always
seconds.
1 hour.
An
So that's
hour
what
is
they mean
always
by
60 minutes.
equal length.
Okay? 1 hour to 2 hours is always 1 hour.
And they're independent of each
So
other.
that's what they
So
mean
one does not
by
influence the other
equal
necessarily.
length. Okay. Although when you see a
And
bunch
they're-
of people
they're
lining
in-
up for
they're
the new
independent of each
iPhone,
other.
so one
There
does
might
not
be an
influence the other
influence
necessarily.
All right, as far as time goes.
Although
Because everybody
when
goes, "Oh
you
my
see a bunch
goodness,
of people lining up for the new
getting
iPhone,
together for we don't
there
we
might
haven't
be
seen
an
World
influence
Series
there
tickets
for a while.
as
But
far
as soon as
time
everybody
goes.
sees the
Because
World
everybody goes,
Series
"Oh my
ticket
goodness,
line forming,
getting together for
everybody
we
forms
haven't
up,
seen World
so
Series
you wouldn't
tickets
be able to
for a
use
while.
Poisson here.
But
You'd
as soon
be
as
able to
everybody
use
sees
chaos.
the
You'd
World
probably
Series
use
ticket line
chaos,
forming,
mathematical theory.
everybody forms up, so you wouldn't be able to use Poisson.
So here's
here.
this
You'd
function.
Use
Handy
chaos.
dandy
You'd probably
function.
use chaos
Okay.
mathematical.
Same
theory.
way as before.
All right.
So here's this function.
As far as
handy dandy
we're
function.
just going to plug and chug,
Okay.
but you got to know what each
Same
of these
way as
numbers
before.
mean.
Okay.
All right. And so
As far
X
as
is the number of
we're just gonna
occurrences
plug
that
and
you're
chug,
going
but
to
you got to know what each of these
examine
numbers
within
mean.
an interval.
Okay. Here's the
And so
probability.
X is the
and
number
here's
of occurrences
the mean
that
number
you're
of
going
occurrences
to
you normally get
examine
in an interval.
within an interval.
Okay.
Here's
the
the value of
probability
E is just 2.71,
and here's the
much like
mean
pi,
number of occurrence
okay,
you
3.14,
normally get in
okay.
an interval.
And then it's X factorial,
Okay.
which
The
is
value of
X
E is just the
2.71, much like pi
of
the number of
3.14,
occurrences in
okay.
an interval.
And then it's X
The
factorial,
trick here is
which
to get
X
all the
the
time intervals the
factorial
same, or all
of
the
number of
the
occurrences
distance
in an
intervals. You could
interval.
do distance as
The
well.
trick
The
here
distance
is to
interval
get
is the same.
all
So you
the
can't
time
do
intervals
meters
the same,
and
or all
kilometers. You
the,
can't do meters
the
and
distance
feet.
intervals.
You can't
You
do
can do distance as well.
the
The
distance
distance
half
intervals
hours
the same.
and
So you can't do
You have to
meters
get everybody
and
everything in the
kilometers. You
same
can't do meters and feet.
the same
You
unit
can't
of
do
measure. You can't do half hours
within
and
the
seconds.
grouping
You
have to get everything in the same unit of measure. Okay, within the grouping of those measures. All right. There's no stated upper limit. Okay.
And so eventually that number is going to get large enough where your probability is going to be 0. So for example, let's take the Best Buy. That number is going to get large enough that 10,000 people are going to walk in the door between noon for example, let's take the Best Buy on a Saturday. Okay. What's the probability that would be 10,000 people are going to walk in the door unless you've got the new iPhone on a Saturday, like that, right? Or that would be almost 0 to none. Unless you've got the new iPhone coming out or something like that, right? 1,000 or There might be they've had them. I mean certainly in places where they had 1,000. Oh no, I said 1,000 new iPhone, right? Okay. 1,000, yeah. All right. There might be they've had them. I mean certainly. And so in places where they had 1,000 people lining up for the new iPhone, right? Okay. Any additional examination of the value of X becomes from a practical standpoint moot. Okay. Any additional examination of the value of X becomes moot. And so let's take a hospital example. It just doesn't matter. I assure you that a hospital, especially an emergency room, has kept statistics. And I was reading an article the other day where statistics and business analytics were going to be the primary emergency room. All things health statistics. And I was reading an article the other day where statistics and business analytics were going to be the primary driver of all things healthcare. An emergency room doc probably costs $50 an hour. Least of which is the example of an emergency room. Okay. Maybe $100. An emergency room doc probably costs. Do you want 2 people who are making $100 an hour there when you only need 1? Maybe $100 an hour. Okay. But do you want 2 people who are making $100 an hour there when you only need 1 in the emergency room at the same time? Is 2 docs going to be enough? If you get 3 people or 4 people or 5 people coming in the emergency room at the same time, is 2 docs going to be enough? Okay, maybe. So you have to staff. But if you get 40 people, telemarketing centers do this all the time. Inbound customer service centers, they know. Okay, so you have to staff telemarketing center at Sprint. Telemarketing centers do this all the time. Inbound customer service centers, they know. And we, when we're in an inbound telemarketing center, anybody seen the pin drop commercial in the very early days, even before it was known as Sprint? Yes, yes. And that ad has been being used since 1988. Anybody seen the pin drop commercial? And that ad was so successful. Yes. That ad has been being used since 1988. That commercial came on TV when there were only maybe 10 channels. And that ad was so successful. And half of them were fuzzy, right? That commercial came on TV when there were only maybe 10 channels. We would get bombed. And half of them were fuzzy, right? 1,000 calls. So, and we only had, when that ad came out, just like that, we would get 5,000 calls. And we had 200 people on the phone. Well, 200 was the max we could do. One time. Boom. Just like that. As a result, and we had 200 people on the phone. They were losing. 200 was the max we could do. They put you on hold. So they can, as a result, delay you coming in. There's a couple other things they can do. I mean, they were losing. They put you on hold. They can delay you coming in. That's right. There's a couple other things they can do. We would use those numbers to justify hiring more people. Hire more people. That's right. And so we would use those numbers to justify hiring more people. And so you put it in your handy-dandy formula here, and you come out with 0.16. Okay? And so and verify that. Now we have handy-dandy tables, and you come out with Poisson as well on page 995. Okay? So and verify that. Now we have handy-dandy tables for Poisson as well on page 995. Normal time. By the way, this is the day we go normal time. Okay? And we're looking at a 995 Poisson table. Yeah, we're looking for the probability. Okay. And the mu in this we're case looking at a 4. What was the probability we're looking for the probability. And X was 4. Okay. So you look across those tables just like you did before. 3. No, it was 3. And X was 4. Right? So you look across those tables just like you did before. 4. 3. Okay. And so you'll see that the probability and X was equal to 4. It's a really powerful tool for people who are trying to staff. So you'll see that the computer system here. And this is everybody trying to get on to the wireless network all at the same time, where you're trying to size that'd be a computer system here. Okay. If everybody tried to get on to the wireless network all at the same time, at the university, would everybody get on? Technical guy at the university has calculated these out, and so this says there's a 16% chance at the university that you're going to get 4 people in. Has calculated these during, and so this says there's a 16% chance that you're going to get 4 people. Now the interesting thing about this is that if you go down and you say, okay, well, what would the probability be that they would get 0 people? Is that if you go down and you say, okay, well, what would the probability be that they would get 0 for this emergency room? We're going to extend this. That you would get 0 people in that 3. What's the probability for this in that half-hour period? Emergency room. Would it be 0? You would get 0 people in that. What's it going to be? In that and then
That's
a
right.
half-hour period.
All right. And so then you
zero?
can keep extending that.
No. What's it
Okay?
going to be?
And then you get down
That's
here
right.
to what's the probability that 9
And
people
so then
are
you
going to
can
walk
keep
in
extending
to the
that
emergency room
okay?
at that time.
And then you get down here to what's the probability that 9 people are going to walk in to the emergency room
Everybody
at that
see
time.
that on the table?
That's right. That's right. Exactly. And now, if you added all those
Everybody see
up,
that on the table?
if you went 1 to
That's
12,
right.
because after 12
That's
it
right,
becomes
exactly.
negligible.
You
And now,
added all
if you
those up,
added
become
all those
dangerously
up,
close to 1.00.
if you went 1 to 12, because after 12 it
So
becomes
now you're the
negligible.
hospital.
You added all
What's
those
the
up,
business
becomes
decision
dangerously
here?
close to 1.00. Okay. So now you're the hospital.
What's the business
what?
decision here?
Why? Do what? Yeah, but if 10, but keep
Why?
in mind that there is a cumulatively close to
Yeah,
a.
but if 10
but keep in mind that
let's
there
call it
is
about,
a cumulatively
80% chance that
close
6 people are
to
gonna walk
a.
in. Let's call it
Cumulative
about
probability. You see what I'm saying?
80%
Cumulative
chance
probability
that 6 people are going to
that
walk in.
About 80.8. Okay.
Cumulative
And this is
probability.
the
You see what I'm
decision.
saying?
This is the
Cumulative
mindset
probability
of the
that
decision makers
about
when they're trying to say,
80.8,
okay, should I staff up
And
or
this
should I
is
just
the-
accept
this is
that
the decision-
hey,
this is
more
the
people are going to be waiting
mindset
in line?
of the
Yes, sir.
decision makers
when they're trying to say, okay, should I staff up or should I just accept
Well, that's
that,
the value
hey,
of E.
more people are going to be waiting in line? Yes, sir, Shane.
Yeah.
That's just E. It's kind of like a pi. It's like pi.
Oh, that's the value of
Pi
E.
is 3.14.
Yeah.
That's just
1.4,
E.
and
It's
you
kind
can
of
carry
like
that
a
out as
pi.
many
It's
times
like
you want.
pi. E. Pi is
Equal to
3.14.
2.718.
1.4, and you can carry that out as many times you want. Always,
E
always. Just like
is
pi
equal
is
to
always
2.14 something.
2.718. Always. Always. Just like pi is always 3.14. And so this is how people staff up. This is how people decide how much equipment to put in. This is how many. This is how they decide how many
this
classrooms
is how
we
people
need
staff
at the University
up.
of
This is how people
Cincinnati
decide
at
how
any
much
one
equipment
time
to
put in. This is how
What's the
this is how
probability
they
that they're
decide how
going
many
to get,
classrooms we need at the University of Cincinnati at any
15,000
one time?
people
Sign up.
What's
Instead
the
of
probability that they're going
sign
to
up
get
for this for next semester instead of 10,000?
15,000
And then you
people
size
sign up
your staff
instead of
faculty sign up for this
rooms,
for
the
next
rooms are the
semester
rooms,
instead of
but
10,000.
even there you have an option.
And then you size your
What's
staff.
the other option if you run out of
faculty,
rooms?
the rooms are the rooms.
Bump them online.
But even there you have an option. What's the other option
Or
if you
you
run
do a
out of
hybrid.
rooms?
Okay.
Bump them online. Or you do a hybrid. And that's what this table is all about here. Okay? You can see that this is the number of arrivals.
Is that
And
at
that's
about
what this
6?
table is all about here.
At about
Okay?
6,
You can see
you're kind of wasting
you
your
can
time to
see
staff
that this is
up
the number of
for any more
arrivals.
people.
Is that
For
at
any
about
more
6
emergency room?
Because there's
At
only
about
like what
6,
2,
you're kind of
3%
wasting your
chance
time
you're
to
gonna get
staff up
overloaded for any more people. For any more emergency room, because there's only like what a 2-3% chance that you're going to get overloaded. Good. All right.